Imagine a civilization that harnesses the power of an entire star. What if we could manipulate the energy of an entire galaxy? These ideas, once considered science fiction, are now the subjects of serious scientific study. One framework that helps us understand the potential of any civilization's technological advancement is the Kardashev Scale. This scale, proposed by Russian scientist Nikolai Kardashev in 1964, categorizes civilizations based on their energy consumption and technological capabilities. Today, we're going to explore the Kardashev Scale and its implications on human civilization. Where do we stand on the scale, and what does our future hold? Could humanity one day become a Type 2 or even a Type 3 civilization? Let's dive deep into these fascinating possibilities and understand what it would take for us to reach these unimaginable heights. What is the Kardashev Scale? The Kardashev Scale, at its core, is a method of measuring a civilization's energy consumption. Kardashev classified civilizations into three main types. Type 1 civilization. A civilization that can utilize and store all of the energy available on its home planet. This includes harnessing all the natural energy sources such as geothermal, wind, solar, and hydroelectric power, as well as controlling all other energy forms like nuclear fusion. Type 2 civilization. A civilization that can harness the energy of its entire star. This would involve constructing megastructures like Dyson Spheres, enormous constructs that encompass a star to capture its energy output. Type 3 civilization. A civilization that controls energy on the scale of an entire galaxy. It could extract energy from billions of stars across the galaxy, essentially gaining mastery over the entire Milky Way. In Kardashev's original model, he only envisioned these three types of civilizations, but subsequent theorists have proposed additional types, including Type Y, control over the energy of the entire universe, and Type Phi, control over multiverses. However, the original three remain the cornerstone of the scale. The path to Type 1. Humanity's current standing, as of now. Humanity has not yet reached the level of a Type 1 civilization. But how close are we? The current state of human technological development is often referred to as being somewhere between Type 0 and Type Y. We're consuming a vast amount of energy from fossil fuels, renewables, and nuclear power. But we're still far from controlling all of the energy available on Earth. We've only tapped into a small fraction of the planet's potential. We rely heavily on fossil fuels for energy, which contributes to climate change, and we haven't fully mastered the technologies required to harness all of Earth's natural resources. However, there are optimistic signs that we could soon make the transition to Type 1. We've begun the shift towards renewable energy sources, such as wind and solar power, and advancements in fusion energy research suggest that we may one day unlock virtually unlimited energy. In fact, fusion has the potential to provide more energy than the entire world currently consumes, and we're making significant strides in this area. If we manage to perfect fusion power, it could accelerate our journey toward becoming a Type I civilization. Beyond energy, we also need to control and optimize other resources such as water, land, and the atmosphere. Technologies like carbon capture, desalination, and geoengineering could play key roles in mitigating the negative impacts of energy production and human expansion. The role of artificial intelligence and automation. Another crucial factor in humanity's potential ascent to Type 1 is the role of artificial intelligence, AI, and automation. These technologies are already transforming industries, from manufacturing to healthcare, by making systems more efficient and reducing human labor. As AI continues to advance, it could help us solve the complex challenges that come with managing an entire planet's resources. Automated systems could be used to monitor and regulate energy production, waste management, and resource distribution on a global scale. With AI optimizing these systems, we could improve sustainability and ensure that resources are used effectively. Additionally, advancements in AI could lead to breakthroughs in fields like agriculture, medicine, and material science, allowing us to increase our overall productivity and further advance toward a Type 1 civilization. But AI also presents its own challenges, particularly in terms of ethics and governance. As we rely more on automated systems, questions around control, accountability, and the potential dangers of superintelligent AI arise. The development of a safe and beneficial AI will be essential as we work towards managing our planet's energy resources and infrastructure. Technological milestones and challenges. To transition to a full-fledged Type 1 civilization, humanity would need to achieve several key milestones in various fields. These include global energy infrastructure, the creation of a worldwide energy network that can efficiently distribute energy from renewable sources across continents. This would involve building better grids and improving energy storage technologies to ensure that clean energy is always available, even when the sun isn't shining or the wind isn't blowing. Sustainable agriculture. In order to sustain a growing global population, agriculture will need to evolve. We could see advances in vertical farming, genetically engineered crops that use fewer resources, and more efficient agricultural methods that allow us to produce more food with less land and water. Space exploration and resources. Becoming a Type 1 civilization may also involve expanding beyond Earth. Space-based resources, such as mining asteroids for rare minerals and setting up solar power stations in space, could significantly supplement the energy needs of humanity. By tapping into space resources, we could relieve pressure on Earth's ecosystems and ensure that energy demands are met without exhausting our home planet's resources. As promising as these advancements are, the road to Type 1 will not be without obstacles. Political and economic challenges, such as global cooperation, wealth inequality, and the ethical implications of advanced technologies, must be navigated carefully. Moreover, the environmental impact of our technological expansion cannot be overlooked, as we must balance progress with sustainability. The road to Type 2. Harnessing the power of the star while humanity is still in the early stages of transitioning toward a Type 1 civilization. The next leap, becoming a Type 2 civilization, seems almost impossibly far away. However, as we continue to explore and push the boundaries of technology, the idea of harnessing the energy of an entire star begins to look less like science fiction and more like a potential future for humanity. What would it take to become a Type 2 civilization? It requires the ability to manipulate the energy output of a star, and there's one concept that immediately comes to mind: the Dyson Sphere. A Dyson Sphere is a hypothetical megastructure that completely surrounds a star, capturing its energy output for use by an advanced civilization. It was first proposed by physicist and engineer Freeman Dyson in 1960. The idea is that as a civilization advances, it will need more and more energy, eventually reaching a point where harnessing energy from its planet or even its solar system is no longer sufficient. A Dyson Sphere, or similar constructs, would allow a civilization to gather energy on an astronomical scale, potentially all the energy emitted by the star itself. There are various theoretical designs for a Dyson Sphere. One approach is to build a solid shell around the star, although this would require materials that are beyond our current capabilities. A more feasible approach might be to construct a swarm of satellites or solar collectors that orbit the star, capturing its energy and transmitting it back to the civilization. This idea has profound implications for how we view energy consumption in the future. To build such a structure, humanity would need to master space construction on an unprecedented scale. The construction of a Dyson Sphere could provide the energy necessary to power entire planets or even interstellar travel, propelling civilization to new heights. But how do we move from our current understanding of energy use to being able to harness a star's power? Technological feats needed to reach Type 2. To begin constructing a Dyson Sphere or similar megastructures, humanity would need to make significant strides in several key areas. Space construction. We would need the ability to build large-scale structures in space. Currently, building anything on the scale of a Dyson Sphere is far beyond our capabilities. However, technologies like 3D printing in space, robotic assembly, and asteroid mining could provide the necessary tools. NASA and other space agencies are already experimenting with building structures in space using resources found in asteroids, and this could be a vital step toward constructing massive energy harvesting structures. Energy efficiency and transmission. Once we have a way to harness the energy of the sun, we would need to transport it back to Earth or other colonies. Current energy transmission methods, like power grids, wouldn't be sufficient for such enormous quantities. One potential solution could be to convert solar energy into microwave or laser beams, which could be transmitted across vast distances. Advanced propulsion systems. Reaching a Type 2 civilization would also require advanced propulsion systems that can carry massive amounts of material and energy across space. Technologies like nuclear fusion or even antimatter propulsion could enable the construction of Dyson swarms or other star harvesting systems, allowing for travel to distant parts of the galaxy. Artificial intelligence and automation. Just as AI will play a critical role in the transition to Type I, it will be just as crucial for the leap to Type 2. The construction and maintenance of a Dyson Sphere would require vast amounts of autonomous robots and AI to manage the intricacies of such a massive project. These AI systems would have to handle everything from resource allocation and construction to energy management and communication between different parts of the sphere. The political and economic hurdles becoming a Type 2 civilization would also require a level of global or even interstellar cooperation that we have not yet achieved. The resources, manpower, and organization required to build such a megastructure would be astronomical, necessitating a level of coordination and shared responsibility that spans across nations or even planets. Economic systems would also need to evolve to accommodate the unprecedented costs and logistics of such a project. Global political structures would need to be able to support interstellar scale endeavors, ensuring that nations or factions work together for the common good rather than competing for limited resources. Issues such as resource distribution, governance, and equity would become paramount as humanity works toward harnessing the power of the stars. Exploring interstellar colonization, in addition to building a Dyson Sphere, becoming a Type 2 civilization, could also mean humanity begins colonizing other planets, moons, and even star systems. With access to the energy of an entire star, human civilization could spread throughout its home solar system, and beyond, establishing colonies on distant planets and moons. Already, space agencies and private companies like SpaceX are laying the groundwork for space exploration, aiming to send humans to Mars and even beyond. However, interstellar travel presents a far greater challenge. To reach other star systems, we would need propulsion technologies that are much more advanced than what we currently possess. Concepts like the Alcubierre warp drive, which theoretically allows for faster-than-light travel by warping spacetime, offer a tantalizing glimpse into the future. If such technologies are realized, humanity could eventually venture beyond the Milky Way, establishing a true interstellar civilization. The potential impact on society. Becoming a Type 2 civilization would have profound effects on every aspect of human society. The mastery over energy would allow for unlimited resources, creating a world, or even a galaxy, where scarcity is no longer an issue. This could eliminate many of the global problems we face today, such as poverty, energy crises, and environmental destruction. However, with immense power comes immense responsibility. The ethical considerations of wielding such power would require careful thought and governance. As humanity advances to the point of harnessing the energy of stars, we must also ensure that we don't repeat the mistakes of our past, especially in terms of how we treat the environments and civilizations we encounter. Ethical guidelines for dealing with new planets, ecosystems, and even extraterrestrial life would be essential. The leap to Type 3. Mastery of the galaxy now. Let's leap forward to the final stage of the Kardashev Scale, Type 3. What would it mean for a civilization to become Type 3, controlling the energy of an entire galaxy? This stage represents the pinnacle of technological achievement. A civilization with vast power, extending its influence across the Milky Way and beyond. At this point, humanity or any other Type 3 civilization would have mastered not just energy generation and storage, but also the ability to manipulate entire star systems. Such civilizations would possess technologies capable of extracting energy from every star in their galaxy, transforming them into galactic-scale entities capable of interstellar colonization and resource management on an unimaginable scale. How would humanity reach Type 3? Reaching a Type 3 civilization would likely require breakthroughs far beyond anything we can currently imagine. To control a galaxy's worth of energy, a civilization would need to have perfected every aspect of space travel, resource management, and energy extraction. It's not enough to control energy at a stellar level, as a Type 2 civilization would. You would need to harness the collective energy of billions of stars, potentially through Dyson Spheres or more advanced technologies that we've yet to conceptualize. Key technologies that could play a role in reaching Type 3 include galactic scale, energy management. A Type 3 civilization could possess methods to channel the energy of multiple galaxies. This could involve tapping into black holes and extracting energy from them using methods such as the Penrose process, which theorizes that a black hole's rotation could be used to extract energy. Superintelligence and advanced AI. At this stage, AI would have evolved far beyond anything we can currently imagine. It would likely be in control of much of the civilization's infrastructure, scientific research, and technological advancements. The ability of superintelligent AI to manage the complex logistics of an entire galaxy, maintaining energy systems, and ensuring the sustainability of numerous star systems would be critical. Intergalactic travel. A Type 3 civilization would have developed the ability to travel between galaxies, not just between star systems. This could involve mastering technologies that allow for the manipulation of space-time on a galactic scale, such as faster-than-light travel or even the creation of wormholes. We're already theorizing about the possibility of traversing space at speeds faster than light. And while it remains in the realm of theoretical physics, the possibility of mastering intergalactic travel seems less far-fetched than it once did. Artificial superstructures. Beyond Dyson spheres, a Type 3 civilization could construct even more advanced structures. For example, structures that span entire solar systems or even use quantum-level manipulation to alter spacetime in ways we cannot currently comprehend. These artificial superstructures could be used to optimize energy use, expand civilization, and facilitate the transportation of materials and energy on a galactic scale. The societal and philosophical implications, as humanity or any civilization ascends to a Type 3 civilization, the social, ethical, and philosophical implications would be profound. If a species can harness the energy of a galaxy, it would have the power to shape the destiny of entire worlds, star systems, and potentially other civilizations. Questions of ethics and governance would become far more complicated. Should such power be used to uplift or control other life forms? What responsibilities would a Type 3 civilization have to less advanced civilizations, especially those that might be encountered along the way? Could they have ethical obligations to intervene in or avoid disrupting the natural evolution of life on other planets? These are some of the questions that would likely arise in a civilization that controls vast cosmic forces. Additionally, the possibility of encountering other intelligent life forms in the galaxy could introduce new challenges. A Type 3 civilization might become the dominant force in its galaxy. But what happens when it encounters another Type 3 civilization, or something far more advanced? The dynamics of intergalactic diplomacy and the ethical questions around first contact would shape the future of any interstellar society. The existential risk of Type 3 civilizations, however, reaching a Type 3 civilization would not come without significant risks. The vast power required to control an entire galaxy could potentially lead to existential dangers. For instance, the uncontrolled use of such immense energy could result in catastrophic consequences, like the destruction of entire star systems, or the destabilization of spacetime. Even with superintelligent AI in charge, there could be unforeseen dangers in the manipulation of such large-scale forces. Moreover, the longer a civilization exists, the more it faces the risks associated with technological stagnation or collapse. Civilizations could fall, not due to external threats, but from internal decay or the inability to adapt to new challenges. Just as the rise of a Type 3 civilization would be an incredible achievement, it could also mark the beginning of an even greater existential crisis for that civilization. What about us? Can humanity become a Type 3 civilization? For humanity, the idea of becoming a Type 3 civilization may seem distant, even impossible. However, considering the rapid pace of technological development we've seen over the past few centuries, it's not entirely out of the realm of possibility. We are making strides in space exploration, AI development, and energy management, which could eventually lay the groundwork for these grander ambitions. The path to becoming a Type 3 civilization is long and fraught with challenges, but the Very fact that we are considering it means that we have already taken the first step toward understanding our place in the universe and the future that could await us. The Kardashev scale serves not just as a measure of energy consumption, but as a powerful tool for contemplating the potential of civilizations in the universe, our own included. Whether we can achieve Type 1, 2, or even 3 status, the journey itself will push the boundaries of human knowledge, discovery, and understanding, propelling us into a future we can only begin to imagine. Conclusion. As we reflect on the Kardashev scale, it becomes clear that our civilization is at a crossroads. We're on the path toward becoming a Type 1 civilization. But what's next? Will humanity ascend further to control the power of a star, or even an entire galaxy? The potential is both awe-inspiring and humbling as we face the vastness of space and the seemingly limitless possibilities before us. The Kardashev scale challenges us to think beyond our current limitations and consider a future where energy is no longer a constraint, and the reach of civilization extends far beyond Earth. The questions it raises are both exciting and daunting. What will it take to reach each new level? What sacrifices will be required? And ultimately, how will humanity choose to use the power that comes with such advancement? As we continue to explore and learn, one thing is certain. The future of human civilization is far more complex and fascinating than we ever imagined.